Shut up and sit down.
Hi, I'm PJ McTavish and welcome back to another DCG tutorial. In this one we're doing the 2011 paper and it's section C, question C3. So as always, this is another question you see here. And this one is a bit of surface geometry, a bit of roofing geometry. So again, I'm not going to read through the question, but we'll just go through the little parts. So part A, surface A and B have a pitch of 50 degrees. Draw the plan and elevation of these two surfaces and determine the dihedral angle between them. Okay, so I'll start off by drawing the elevation plan of surfaces A and B, and then we'll go through how to get the dihedral angle. So far this is as much as I can do of A and B. So this is telling you that that's A there, that's surface A. This is a portion of B. Again, you have surface A here, and you have surface B. So what I do know is that we're at a right angle coming up here to a point up here, so we don't know the height for this point. We can see the height in elevation, but we don't know where this line ends. Also what I have is this line on the surface B is on the ground, which is this line here, and it's on the ground and it's parallel to the, well, if it's on the ground, it's going to be true length. So if I project my points up here, parallel to that, put a new x1, y1, I'll get a point view of that line. It would give me edge view of B. And you know B is at incline of 50 degrees, it's a pitch of 50 degrees. So we should be able to work backwards then and finish off the plan. This is our pitch of 50 degrees. That's your horizontal plane. And we know the height of the surface B, which is this point here, which we're trying to kind of find there, is this height here off the x1, y1. So mark that height up, draw a line parallel to x1 and y1, and this tells you where surface B ends. So bring that point back down and tell you when surface B finishes. So now finish off the plan. Now a little recap on that before we move on. We had a true length here of one of the edges on surface B, so we projected that up to find a point view of it. Once we got a point view, we knew the pitch was 50 degrees, so by putting in 50 degrees and also knowing the height from the elevation, thanks to this vertical line here, we could put in the height and draw it across, put in our 50 degrees and figure out where this point is. And this point represents the top point here of the line section between A and B. Once that was found, then it was straightforward after that, because you know it was 45 degrees for this line here, so that's 45 degrees here in this angle of the triangle, which left you at 90 there. So it had to be, this line had to be 45 degrees because the two of them made up 90, and 2 90s equals 180. So that is the plan and elevation of surface A and B, and the last part of that is, they said, determine the dihedral angle between them. So now that we have the line section between them, I can just go to draw a view perpendicular to it, find a true length, and then get the dihedral angle in the second auxiliary view. So I'm just going to keep this auxiliary view a bit light so that it doesn't go over everything else, or it doesn't get too confusing. So what we're doing is, this is your line section. Project it up perpendicular to it, and it is here and here, so that's your line section there. So that's a true length now, and if we project down parallel to that, we get the Dihedral angle, and we can go actually down here, there's a bit of space there, and we'll put into that line to save us a bit of room. So there's our Dihedral angle between surface A, which is in red, and surface B, which is in blue. Now I didn't label the points, which might make it a bit easier for you as you're projecting them up, because it's just as easy to do it in just following my lines, put them in with a dot, and then bring them down. So once we found the plan, this is your line section between the two planes. Go perpendicular, and also then go parallel into your line section. Gives you point view of the line section, and that's your two edges, just like coordinate geometry. Now it is a bit messy looking because I've gone over the original auxiliary view there to find the plan of B, but as long as it's light, this is the main thing. This is what counts. This is where your marks are. Now part B, the opposite edges PQ and RS of the surface D are parallel. Draw the plan elevation of surfaces C and D. So surface C and D. So PQ and RS are parallel. So continuing up that 45-degree line from surface B and come straight across here from this point here, that's giving us point P. So I'll put that in with green just so it's different. This is point P. R is straight across from this point here, so let's bring that across. This is point R. Sorry, this is point Q. Now we can find them in the elevation just by projecting them straight up. P is on the XY line, and Q is the same height as the other surfaces there. So this is point P, this is point Q. Now for D, and we're continuing straight across from the base of B here. And from point P, which is the apex of that triangle there, we have a 45-degree angle here at the edge of surface D. So if I bring 45 degrees down from Q like so, because it'll be at a right angle to that edge there. So what we're getting here is we have our 45-degree angle here, 45 here, and that gives you your 90 up at the top there. So this is point R down here. And remember they're parallel. So if I go 45 degrees from R, I'll get point S. And to find point S then on that line, project R up to the elevation. R is on the ground line, as you see there in the question. And remember I said they're parallel, the edges are parallel. So if I join P to Q, sorry, it's a different height over here. So if you look at the measurements, it says it's 2 meters from R over to S here, and we know that it's on that 45-degree line here. So if I measure across my 20 mil, now I can project point S up, and I can get my parallel line and figure out the height and elevation. So PQ is the same angle as RS. So by projecting that across from point R on the XY line, you will get point S, i.e. the height for S. So this is point S here. Okay, so let's draw down strong just so it stands out and it looks a bit better. Okay, so that is the elevation plan of surfaces C and D. I might just label them as well. And okay, so that's part B. Now part C, the dihedral angle between surfaces D and E is 125 degrees. Complete the projections of surface E. So the angle is 125 degrees. So what we need to do is do our auxiliary views and then find it. So to get the edges of E, let's see what they've given us. So straight out from S and over 2 meters gives us the edge. So we can find the plan. Okay, good. So oh yeah, but we can't find the distance down. Okay, so that's E inside here. Now let's project that up to the elevation. Okay, so it's this corner point here and this length down there for E is what we need to find. So the dihedral angle is 125 degrees. So just like before, if we project our first auxiliary view and then put in our second one with the angle, we can work backwards in order to finish surface E here. Okay, so your line of section is the line RS, so project perpendicular to that, put in your x1, y1, get your height from the elevation. Okay, so I might have to add on another sheet here, so I might just zoom in on this section here. But as you can see, it's giving you, the first auxiliary view is giving you an edge view of the surface, PQRS, and the line of section is RS, which is from here, which is your full line here. So the next view is going to be parallel to it, so I can project out here to the right hand side, and we're going to put in our dihedral angle. Okay, so that's our edge view of our surface PQRS. The line of section is the line RS, so project that out. Put in a new x2, y2, which is going to be perpendicular to that. You're working from the auxiliary view here back. So what you should get is a point view of the line RS, if you will. It's the same height. Let's get that marked in first. And then the distance back for P and Q will give you a point as well, because they're the same distance. Now let's mark in our dihedral angle. Okay, so just working backwards, we have our dihedral angle of 125 degrees put in here. We know for this view we're getting a height from the x1, y1 back. Now we have one point on the surface E, which is this height here, so let's accurately bring that back to the x1, y1, and it will be projected down here somewhere. Get that height. Mark it up from the x2, y2. And we'll draw that parallel to the x2, y2 till it cuts our angle, which is here. So that gives us a point on surface E, which is this point here. So if I project that back at the same angle, it would tell us where that line stops in the first auxiliary view. So this is a point on the surface here, and because this is auxiliary elevation, that height for this point here, we'll name that point Z. This is point Z here. It shrinks back to S actually. Because this is auxiliary elevation, if I get the height from the x1, y1 to point Z, that represents the height from the x, y line up. Now, I don't know how clearly you can see it there, but as I marked in my height from the auxiliary elevation for that point Z, give me my height here. Now that is actually slightly above the height here. And if you look at the question, it's actually below it. So I paused there and tried to have a look back again and see, but either I've made a mistake with the height here, which I don't think I have, because it's very simple. Like, it's just your measurement, you're 50 degrees and up, and straight up. So I don't think there's anything wrong there. So what I'm thinking is either with my angles going out here, or even with using the pen over again, that maybe my 125 is slightly off a bit there, but I can't see a reason why it would be so far off. Because if we go through a recap on it, our point Z here on the E surface, okay, which is the one we're trying to find up here in elevation, that point Z, you project it down for your first auxiliary view. This is auxiliary elevation. You don't have a height, so you can't find it. Fair enough. You have your line section, you go parallel to it, you put in your edge view of that surface D, and you know the angle, the dihedral angle between the two is 125 degrees. So we put in 125 degrees. And our height then, because you're working for the heights for this second auxiliary view from the x1, y1 back to the plan, we have that distance for Z. So if you put in that height up and drew a line parallel to the x2, y2, where it cuts your 125 degree line, that has to be point Z in the auxiliary view. So if that's point Z, project it back, same angle to this auxiliary view, and you have your projection line already from Z here, where they meet, that has to be point Z. And if this is an auxiliary elevation, then that height from the x1, y1 up to Z is the same height from the xy line up to Z here in elevation. So I can't see myself what has gone wrong at it. Maybe if there's any teachers watching this, you can let me know what you think. Or even any students that have done it out and it has worked out below it, let me know how you got on with it. But I'm just going to continue on, draw in strong, and then go through finishing off the plan. Now to finish off surface E in the plan, you note that there is, so this is, I'll just label that again, this is point Z up here, okay? So to find that point at the ground, it's in line, it's underneath point Z here, the vertical line here, so it's in line with it there. You don't know the angle here from R up to that point. But as you see in the elevation, it is a horizontal line. It is on the horizontal plane. So basically it's a horizontal trace. That line from R coming across here for plane E will actually be on the horizontal plane. So in order to find a horizontal line, or a line parallel to that horizontal trace in the plan, I'm going to draw a horizontal line on my plane. And for this one, we're going to go from Z straight across horizontally to the line RS. Project that point on the line RS down to line RS in plan, connect it back to Z, and you'll have a true length, and you'll also have a line that is parallel to the horizontal trace in plan. So by drawing a line, we knew this line was horizontal because it's there on the XY line. And by drawing a line on the plane from point Z, which we have in plan, we have one of those points, or that point Z is the point we have in plan. By drawing a horizontal line from Z to where it cuts the opposite edge of the plane, which is RS, project that point back down to the RS in plan, connect back to Z. That line is now parallel to your baseline here. Okay, but we didn't have the baseline, so once we found that angle, copy that angle from R, and that finishes off surface E. So just a small bit of shading on there so it stands out. So just to recap on that, with the method here for the last part of the question, I can't see where I've gone wrong. I'm assuming I've gone wrong somewhere, seen as obviously it's wrong compared to the question that point Z is actually too high here in the elevation. But working backwards, I can figure out where it could be, because I can't see any fault with the reasoning there, because this is an auxiliary elevation, and it's the same as like your coordinate geometry question where they leave out a height for a point, like the previous video I uploaded. So anyways, I can't see anything wrong. I can't see where I went wrong. If you do it out yourself, or if you've done this question before, just you can let me know in the comments and what you think is wrong with it, or where you went right with it, or if you went wrong with it yourself. Also, again, I'm using 2B pencil to do the construction lines, which I'm hating because it's leaving so much mess on the sheet when you're going over it with the T-square. It's leaving so much graphite on the page. But let me know in the comments if that works better than the 2H, if you see the construction lines a bit better and if it stands out a bit better. Personally, I think it looks okay on the laptop anyway, so you can let me know in the comment section below. So as always, I hope that helped. If it did, leave a like, and we'll see you in the next one.